So today is day 4 of my DSA preparation. So the questions I solved were, first one was flattening the bandit into linked list. We solved it using Morris traversal. Second was search in BST binary search tree. Third was validating if it's the correct binary search tree. And then finding kth smallest element in binary search tree. And finding predecessor and successor in binary search tree. And last not the least common ancestor or two node in a binary search tree. So regarding the flattening of binary tree into the linked list, it follows the typical like the merge traversal procedure. Just here is the code. What we need to remember is okay, just follow the algorithm here because without knowing it, it's a bit difficult to face. But here we calculate the predecessor. After calculate the predecessor, we just change a few links and convert it from a tree to linked list. The two main things, if you remember, that will be easier. Like creating the current node, keeping the current at the root, and we will move it for in the process. And we need to find the predecessor of the current, basically the root at the starting, and after that we have to change a few links so that we can convert a tree into linked list. And search in binary search tree, like it's very simple. Basically binary search tree feels a bit similar to the binary search we studied. So what I did, binary search, okay, element is present or not, null false. If yeah, it's very simple. Okay, validating. This was very interesting. Basically, we define int at for each node. We define the value range. It, matlab in what range value is allowed for that node. So and we traverse the entire node and checked if it is true or not. Matlab, if the value lies in that range. If it lies, then it's true. If not, then false. And this was a bit like good method, like keeping the like it was similar to the work we did in tree, like keeping pair or dictionary or path. So here basically we uh, kept the value range permissible for each node. Finding kth smallest element, basically first I calculated the in order traversal for this binary search tree, and we know that the in order traversal for BST comes in a sorted way. So from there I calculated the kth small element. So basically this is the code to create in order. After that we got a vector. After getting, we simply got the kth smallest element. And for getting predecessor and successor, I did the same. First created the in order. Now from the in order we have a sorted list of matlab great sorted list of me, and from there I solved the problem. This was a bit interesting. I couldn't solve it from my own. I had to take help, but yeah, this was really good. This part, least common ancestor, uh, we can solve it in the way we solve least common ancestor of a tree, but that was very lengthy. It's a very simple approach and it's very interesting.